Hello, what's going on? Mr. Sutton here with the Pre-Cal Honors 4-5 Extra Practice Number 3 solutions on logarithmic equations. For this problem, to get started, I want to isolate my log expression. Let me do that by subtracting 1 from both sides. And then to get rid of log base 11, I have to raise 11 to both sides. That leaves me with b equals 11 to the 1, so b equals 11. If I plug 11 back in, I'm not taking the log of 0 or a negative number, so 11 is it. To solve this log equation, I first need to make sure I have at most one log on each side. On the left side, I notice I've got these two logarithms being added together. Well, I can combine those into a single log by multiplying the things inside. So this is really going to be log base 5 of negative 9x on that side, and we still have 3 on the other side. Now, to get rid of this log, I have to raise the base 5 to both sides. That cancels out the log base 5 on the left. We just have negative 9x. On the right, we're going to have 5 to the third power, which is 125. And dividing both sides by negative 9, that's going to be negative 125 over 9. Now, if I plug that back into the original equation, that's going to give me a positive inside this log, which is perfectly fine. So I'm going to take that as my final answer. For this problem, I'm going to start this off by dividing both sides by negative 10 to get the log expression by itself. So that's a 4 over on the right side. And now to get rid of log base 6, I raise 6 to both sides. So that's going to be x equals 6 to the 4th. And what is 6 to the 4th? Well, let's see. 6 to the 3rd is 216. 6 times 200 is 1200. 6 times 16 is 96. So that's going to be 1296 altogether. And if I plug that back in, I'm not taking the log of a negative number or 0. So we're good to go. On this problem, since we have a log that's the same base on both sides and nothing else, we can just cancel the logs out, or you can think of this as raising the base 2 to both sides of the equation. Either way, we end up with p squared equals 3 minus 2p. Since I've got a quadratic, I'm going to get everything on the left side and try to factor this thing. So we've got p squared plus 2p minus 3 equals 0. And then two numbers that multiply at a negative 3 and add up to 2. That's going to be positive 3 and negative 1. So that means p equals 1 or negative 3. Now, do these both work? Well, if I plug 1 in, I get a positive there, I get a positive over there. That's inside the log, so 1 works out just fine. If I plug in negative 3, p squared, that's going to be a positive in there. Over here, I'm going to be doing 3 minus a negative, so that also is just fine. So these both work, giving me two different answers. On this problem, I've got a log inside a log. This is craziness here. But we're just going to tackle this the same way we would any log problem. Just raise the base to both sides and keep doing that until we run out of logs. So we'll start by raising the base of 16 to both sides, since 16 is the outer log that we need to get rid of first. 16 to all of this stuff is going to cancel out log base 16, leaving me with log base 2 of 512x on the left side. Over here I've got 16 to the 1/2, which is really the square root of 16, which is 4. Next, to get rid of this log, I need to raise 2 to both sides. So that's going to be just 512x equals 2 to the 4th. And now just divide both sides by 512 to get x alone. So we have 16 over 512. Now, to do this without a calculator, it helps if you realize that you've got 2 to the 4th over, this is actually 2 to the 9th. That would give us 1 over 2 to the 5th, or 1 over 32. For this problem, I notice that I have a log base 2 on each side of the equation, and that's it. To get rid of those logs, I can raise 2 to both sides of the equation, leaving me with just x equals 2x minus 1. And then solving, let's see, subtract x from one side, add 1 to the other. We end up with x equals 1. If I plug that back in, I'm not taking the log of 0 or a negative number, so x equals 1 is my answer then. On this problem, in order to get to the bottom of this one, I notice that I have multiple logs on the left side of the equation. I want at most one log on each side. So let me merge these two logs together. Since I'm subtracting them, that means I can divide the things inside. So I can rewrite the left side of my equation as log base 8 of 5 over x minus 2. And now that I have just a single log on each side, I can get rid of those by raising the base, which is 8, to both sides, so basically canceling out the logs. That leaves us with 5 over x minus 2 equals 69. And now we just have to solve for x. So there's a few ways to do that at this point. Probably the most straightforward is just to multiply both sides by x minus 2 and distribute the 69 to that. So on the right side then I'll have 69x minus, 69 times 2, that's going to be 138. And then add the 138 over to the left side, that's 143. Divide that by 69, we have x equals 143 over 69, which cannot be reduced. Now, if you plug this back into the original, the only thing you have to be careful of is this x minus 2 term. 143 over 69 is a little bit more than 2. So if I plug that in here, I'm not going to be getting a negative number inside the log. So we're good to go with this answer. On this problem, I noticed that I have logs on both sides, and it's the same base e for both of these. So to solve this equation, I can start by raising e to both sides of the equation, or just simply canceling the logs out. So that's going to be v squared minus 2 equals negative 6v minus 2. And let's just get everything on one side, because this looks like it's going to be a basic quadratic kind of equation. So add 2 over here, that actually cancels out the negative 2, so that's just 0 for that. And we'll add the 6v over to the left side as well. So we have v squared plus 6v equals 0. This one I can factor out of v, so this is going to be v plus 6 left inside. And I see then that I have v values of 0 and negative 6. Now you always have to double check and make sure you're not going to get 0 or undefined when you plug these back in. If I plug 0 back in, up here I'm going to have 0 squared minus 2, which is going to give me a negative inside. I'm going to get a negative 2 inside this log as well. Now it doesn't matter that these happen to have the same negative number inside. You can't take the log of a negative. So 0 actually makes the original undefined, and it's an extraneous root. We have to cross it out. Plugging in negative 6, that's going to give us, 36 minus 2 is okay. 36 minus 2 over here is also okay. So negative 6 works, and it's the only answer that we can take through to the end here.